네, 반갑습니다. SiA 전태균입니다.
Nice to meet you. I am Taegyun. First of all, thank you for inviting me to speak before you in this auspicious event. Today, I'd like to talk about harnessing AI for Geo-Intelligence, focusing on imagery analysis with AI. Now, we live in one planet, same Earth, but we have different views on the economy, nation, environment, and climate. There may be different approaches on how to bring these different perspectives together, but today I'd like to focus my talk on imagery in and aero imagery, especially satellite, drones, etc. And that is why we try to combine technologies in satellite and AI to make life better for people. First of all, our business area is geospatial intelligence, artificial intelligence, and combining those two, geo-AI. I am sure some of you have not heard of us. SiA is a daughter company of Cetra. We started recently, established in 2018. And our mission is to achieve evolve through AI and deep learning technology. So we do focus much on applying AI technology for imagery analysis. We build AI models, and utilizing these AI models and analytics, we also provide services based on systems and platforms. So these are some track records that I can share with you. So we are recognized with our technology globally. Various segmentations like buildings, roads, and other infrastructures and structures that are key components in a metaverse are some of the interest areas for our firm as well. We do not have a robust data, especially in the AI sector, so we are trying to combine and build more components on data for AI and analytics. Defense is one of the key areas we work with also, especially in damage assessment. And more recently, we are focusing also in climate change and climate issues. So carbon mapping and other technological components are some of the things that we are working on. Today's topic, I believe, is focusing on more recent technological developments, and this is the slide to reflect that. We have a hype graph of adoption, and we can see a growing level of expectation for the technologies. And when it peaks, what type of service it can provide is what you can read off this slide. And we know that many agencies have had their share of trial and error, and we are discovering what is possible and what is not through these technologies. On the far right, there are some geodetecting technologies for defense and intelligence, and some of the peaking technologies are carbon mapping, then there are flood mapping, climate risk, etc., that are increasing in the expectation level of technology. NVIDIA, MXR Planet, and other partners and collaborators are working with us, just to give you an idea of our business. And recently, our mother company Satrec and Hanwha, which is the biggest defense and aerospace company in Korea, has formed a consortium, and a Satrec initiative will be launching a commercial Earth observation satellite soon, which and it will use AI-powered technology to provide greater value to the community. Now, going a little bit more into details, satellite, drones, and aerial photographs have suffered the challenges of dimension and resolution. So the quality of visual is key here. And there have been a lot of technological advancements that we've seen in the field, but we do not see real cases that take full advantage of those advancements. So we have launched Super X to enhance the resolution and visual of the imagery that you receive from your sensors. And this is a planet scope, as you see from the slide, and the dimension and resolution is greatly enhanced, as you can compare the left and right side of the slide. So we have signed a contract recently for enhancing the data from the EO data. Satellite operator and organization with EO data has signed a contract with us, and some of the other samples are here to show you how the resolution is enhanced up to 15 centimeter level with satellite imagery. That's a great advancement. And I also know that many of you are in geospatial data and geospatial, especially satellite imagery data experts. And I would like to invite you to reach out to us whenever you feel the need to. We would be excited to work with you. And in recent years, we have been working with satellite imagery and AI analysis, and most of those day-to-day work includes collecting data and analyzing them, and the segmentation of deformable data and classification. These are the main things that is done. And if I can go through them one by one briefly, I think it would be more useful if you can see them through an actual case. So these are some of the satellite imageries. We combine imagery from commercial satellites and EO satellites, and so this allows you to detect your target, process the imagery, and do AI analytics, and provide a report. This is done in one platform. And currently, in the US and in Asia, Google Cloud and Amazon is the cloud service that we use to provide our service. And we are seeing a lot of satellite imagery resources exponentially increasing, and I'm sure many of you are facing that challenge and trying to tackle that. And our response to that on the back end was technological advancement, and I am happy to present some of these outcomes with you today. One of the use cases that we had in the U.S. defense area was with maritime safety and maritime monitoring. And this has to do with detecting fishing boats that keep their signaling components off for UUI fishing. And you can see in this imagery that there are two ships side by side, and this is illegal shipping and transaction happening offshore. So these imagery detection technologies will allow you to figure out where the ship, not just where the ship is, but where it is heading, which way it is positioned, and the actions happening around them. Also in the US, some cases have to do with crop production. This has to do with classifying plots and forecasting crop production from those plots. And the prediction and forecasting level has surpass the level of existing systems. So the NASA Harvest team used to work on a crop diminishing due to wars and the outcome or influence of wars on crop production. So that was in the agricultural area. Another use case is on manufacturing outcomes. This is in San Francisco. I believe this is from Tesla's port, where they ship out their productions. However, the actual logistics data in this local area was not very accessible. Satellite imagery can solve this problem. You can actually make and pinpoint the data whether they are accurate or not with satellite imagery. Going beyond that, meteorological satellite data is one of the most devaluated satellite data, I would say. And the challenge is when to point where to be able to see through the clouds. And scheduling is key here. So you need to be able to forecast and predict where you will point your camera to get an accurate and high-resolution, clear view of your satellite imagery. Also, GK2A dataset allowed us to interpolate those data to fill in the gaps in our dataset. So the previously resolution enhancement technology, the super resolution technology, added with the GK2A dataset, helped greatly to improve our meteorological satellite data quality. In addition, domestically, this has been a growing concern, and globally also, it's flooding and inundation. Natural disaster recovery asks for a lot of satellite imagery analysis for prevention methods and prevention purposes. These buildings that are marked in pink mean they were damaged. And this is useful data for investors that invest into this local area, or facility managers, operators, and responders who need to respond for recovery. It does not require a dedicated monitoring system because you can have an overall view with the satellite imagery, and these technologies are very useful in these areas for serving these purposes for recovery. And finally, this has to do with greenhouse gas. The satellite data is used along with the CO2 detection model, and we also have sensors on the ground to add to the satellite data. This case in particular is from Paris, France. And the data comes in regularly per time, per location, and each plot or segmented plot will provide different data of CO2 emission, and that allows you to have a forecast of what area in particular has more CO2 emission or greenhouse gas. So some of the cases that I've shared with you is not just for show. It's actually a working reference, and it is in operation currently. Our processing data volume is about 1.2 million square kilometers daily, and we do use the cloud when needed. I hope that was useful information for you. And as you know, geospatial intelligence is a new arising field. I would like to tell you that there are upcoming players in the market and in the fields that are very capable, and I hope These cases help you inspire to build a better tomorrow for all of us, and I am happy that we are joining in advancing the technology to help that. Thank you very much.